Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 4, Section 1, Chapter 7, Topic 1. Understanding Fatigue and Life Prediction in Semiconductor Packaging. Introduction. Fatigue and life prediction play a crucial role in semiconductor packaging, where devices are subjected to cyclic loading, thermal stresses, and environmental factors throughout their operational lifespan. Predicting the fatigue behavior and estimating the expected life of semiconductor packages are essential for ensuring reliability, durability, and performance. This overview explores the concept of fatigue, discusses methodologies for life prediction, examines factors influencing fatigue in semiconductor packaging, and outlines strategies for improving reliability through fatigue management. Understanding fatigue in semiconductor packaging. Fatigue is the progressive and localized structural damage that occurs when materials undergo repeated cyclic loading below their yield strength. In semiconductor packaging, fatigue can manifest as crack initiation, propagation, and eventual failure due to mechanical, thermal, and environmental stresses. The fatigue process involves several stages.
Crack initiation. Microscopic defects, such as inclusions, voids, or dislocations, act as stress concentrators, leading to crack initiation at critical locations in the material. Crack propagation. Cracks propagate incrementally with each loading cycle, driven by cyclic stresses and material degradation mechanisms, such as cyclic slip, dislocation movement, and crack tip plasticity. Final fracture. Cracks reach a critical size, resulting in catastrophic failure of the material, often characterized by sudden fracture and loss of structural integrity.
Methodologies for life prediction. Several methodologies are employed for predicting fatigue and estimating the life of semiconductor packages.
Empirical models. Empirical models, such as SN curves, stress life curves, and EN curves, strain life curves, quantify the relationship between stress or strain amplitude and the number of cycles to failure based on experimental data. Analytical models. Analytical models, such as linear elastic fracture mechanics, LEFM, and Paris law, describe crack propagation behavior using mathematical equations based on fracture mechanics principles and material properties.
Finite element analysis, FE.
FE simulates stress distributions, deformation behaviors, and crack propagation paths in semiconductor packages under mechanical, thermal, or environmental loading conditions, providing insights into fatigue behavior and life prediction. Damage accumulation models. Damage accumulation models predict fatigue life by integrating fatigue damage mechanisms, such as crack growth, material degradation, and cumulative damage accumulation, over time. Probabilistic models. Probabilistic models assess the probability of fatigue failure by considering uncertainties in material properties, loading conditions, and environmental factors, providing probabilistic estimates of fatigue life and reliability.
Factors influencing fatigue in semiconductor packaging. Several factors influence fatigue behavior in semiconductor packaging.
Material properties. Material properties, such as modulus of elasticity, yield strength, fracture toughness, fatigue strength, and thermal expansion coefficient, influence the fatigue resistance and durability of semiconductor packaging materials.
Loading conditions.
Loading conditions, including cyclic stresses, thermal gradients, mechanical vibrations, and environmental exposures, dictate the severity and frequency of fatigue loading, affecting crack initiation and propagation rates.
Package design. Package design features, such as geometry, dimensions, interfaces, and stress concentrations, influence the distribution of stresses and strains, as well as the likelihood of crack initiation and growth in semiconductor packages. Manufacturing processes. Manufacturing processes, such as molding, bonding, soldering, and assembly, introduce residual stresses, defects, and material imperfections that can serve as initiation sites for fatigue cracks. Environmental factors. Environmental factors, such as temperature fluctuations, humidity levels, chemical exposure, and mechanical shocks, accelerate material degradation, fatigue degradation, and crack propagation in semiconductor packages. Thanks for watching. Please like, share, and subscribe.